Hey, good morning.
Hey, good morning. Okay.
Hey, Matty, how are you doing today?
Good. How are you?
Doing well. I thought we would.
Did you physically move as well?
I
Hey
thought we'd
guys,
start with.
can you hear
Yeah.
me?
Yep. I can hear you good. How you doing?
Hey, good.
Hello, hello. Good morning.
Good morning. Hey, Chris. How's it going?
Good, good.
So Ed's saying that he's having some trouble joining the Zoom meeting. Anybody else has any trouble? Okay.
No.
No, it's make sure he has the right link. We recently did change a lot of the meeting invites to point each CNCF working group to have its own specific Zoom. So he could be using an old one.
Oh, okay.
That's my theory, at least. But I posted the link for the Zoom in the chat. So.
Hey, Lee. How you doing? Deepak. Thanks for joining. Did all of you guys get an invite to join the Google? I'm sorry, the networking work group email list that CNCF set up for us?
This is Madhu here. I didn't get anything like that.
Okay, I'll make sure you get that.
Thank you.
Yeah, same for me. I don't know. I think I am in a mailing list from past, but I haven't seen anything recently.
Okay, I'm gonna post the mailing list in the chat, and you guys can join it right now.
Hey, Lee. Good to see
Okay.
you.
So if you want to go to that, send a join request to that.
Hey everyone, this is Roy from Cisco.
Hey, how you doing? That you could get on, Ed. Was it the link or was it something else?
Not sure. Got here now.
Okay, well, cool. All right, so we have a pretty packed agenda, so we'll get started. Madhu, if you want to I thought we'd begin with kind of an overview of CMN. This is something that, like in our first meeting months ago, we wanted to get to, and for whatever reason, calendars and vacations and other things, it just sort of kept getting like delayed. So it's great to have that discussion now, and then we're going to have the Cisco team is going to present Project Contiv for the second part of the meeting. So
sure, I will. I have 30 minutes, right? So I will try to quickly cover things. Let me share my screen, and I'm looking for it as always. So give me a second. I'm trying to share my screen. There you go. Okay. Okay, not this. Ah, crap. Software. Okay, I guess it's sharing now. Can you see it now?
Yeah.
All right, excellent. So as Ken said a few weeks back, we had a discussion about various interfaces and models that we follow currently. And in Docker, we follow CNM, which is Container Network Model. So here I'm going to give a high-level overview of what CNM is and how it is not a competing standard with CNI, whether they can work together, and how we are actually changing the lib network architecture to work on both CNM and CNI at the same time. So here, to give an understanding of what CNM represents, I have a few slides here to cover in 30 minutes. So CNM essentially is a network abstraction for applications and container platform. So the idea is that we wanted to come up with an easier to use network abstractions like the network objects, which the applications need not worry about. At the same time, when Docker, as we look at Docker's evolution, Docker has gone, the way the compute has evolved in Docker is to make sure that an application can work the same way in laptop or in the cloud or in the on-prem systems. So we took a similar approach for networking. And in order to do that, what should be the abstraction in a way that all the complexities of the portability and simplicity is managed under the abstraction, while the applications that is deployed on Docker or any other container systems just make use of CNM as a way to interface with the abstracted concept. So that's how we started with this. And one of the other primary design goals we had was to make sure that to build a modular and very composable components, such a way that one can replace the components in a very composable way, essentially. And in order to provide a proper abstraction, we thought about not just doing the low-level driver interface, which is the CNI that we all know about, but we also do the high-level network management pieces as well. That's part of CNM, the concept. So the goal that when we started is to provide application portability and simplicity to the networking layer. And libnetwork is the project that's actually implementation of what CNM is today. So again, the design goal when we started like 2.5 years ago is to provide an abstraction to bring in application portability across infrastructures and providers. That's the design goal that we originally had. So I took few slides from other presentation I made just to give an idea of how the abstractions have evolved and how and where we think our concept of CNM stands. So we all know about this, the standard driven networking, where the standards like the protocols, the IETF is where the IEEE is where the standards evolved, and RFCs are the way we define the interoperability, and that's how we started. Then came the wave of software-defined networking with a few of us in the call here who have worked on it in the past by defining various controllers and mechanisms like the open delay controller and so on and so forth to provide a software-defined way of managing the networks. Then projects like OpenStack started using such a concept for managing the infrastructure. Then it evolved into a next bigger piece of policy-driven networking where the operators can define policies for a particular application, and things can start working at a different abstraction level altogether. So at Docker, we wanted to evolve that approach, take the abstraction to the next level to make sure that the abstraction doesn't expose a lot of networking details to the applications, while providing all the flexibility and complexity, the flexibility and simplicity of networking that we can provide, just like the way Docker expects it to work. So that's when the CNM started coming in. So CNM, when we started CNM, the biggest abstraction that we felt, which is really useful when it comes to containers, is that prior to the container networking, applications were kind of two steps away from networking, where even if you look at virtual machines, networking was done at the hypervisor layer, while applications again worked at the concept of a host interacting with the network. But with containers, we get an opportunity to actually make an impact on the application stack directly, because the namespace in which we can actually own the namespace at the container platform level, so we can actually have a direct impact on applications at an abstraction level. So we took this approach of evolving the abstraction and then go into the container space on how the abstraction can actually help the applications in a much bigger way. So the way we saw CNM evolve was to see how the applications look at networking and how infrastructure look at networking. So I have several slides that we all understand on how application interacts with networking. For example, a current application today will interact using DNS or RPlayer or TCP/IP. Right? These are the layers where we interact with application. Application interacts with networking. That's where the abstraction stops the applications. While infrastructure dimension looks at a different way. Infrastructure, we know about management plane, control plane, and data plane. Management plane takes care of all the managing the network resources, like the UX, CLI, managing the controlling the configuring the network, and so on and so forth. While control plane takes care of signaling between the network entities. That includes OpenFlow, OSDB, OSPF, so on and so forth. And data plane is the actual movement of the data bytes. And in this case, it's the drivers that we all are aware of, like the VXLAN, Bridge, or MAC-VLAN, so on and so forth. So the goal was to make sure that provide an abstraction that is multidimensional. It's not just trying to satisfy infrastructure view or the applications view. Rather, provide an abstraction that is simple enough to take care of this both dimensions in a proper abstracted way. And thus came CNM, where we thought about, hey, how do we get this multidimensional view of networking all abstracted in a way that when users deploy their application stack, things just work without having to worry about the networking complexities that we worry about, and pushing the network complexities to the network drivers that actually does the job of moving the bits from A to B. So in CNM, we have the concept of sandbox, endpoint, and network. These are not the driver concepts yet. These are abstracted objects which will be used by the management plane to configure these objects, and which will get translated down the line to the network driver APIs that can be CNI. That's what we are working on today. So here we see that there are three objects, as you can see here: sandbox, endpoint, and network. For simplicity, I will just try to give comparisons on this one. Network is the logical view of two endpoints talking to each other. Endpoint is the interface that is connecting given network namespace to the network, and sandbox itself is the equivalent of network namespace. But sandbox, we don't call it network namespace here just because Docker is a multi-platform solution, multi-OS solution, and Windows and other systems doesn't call it network namespace, other they have the different concepts. So libnetwork, if you look at the implementation, we have sandbox for various platforms. So sandbox is the right concept here, but for our discussion, we can just think it as a network namespace of a container or not. It can also be a standalone namespace doing some special purpose network services like load balancing or DNS or so on and so forth. So this is the simplest model that applications view of, and the network management view of the CNM is pretty much that's it. So how we manipulate this one, how we implement this abstraction with various components is where the libnetwork and the drivers actual role comes in, essentially. So okay, here the way Docker uses CNM is that libnetwork is the project on its own. It can actually work independent of Docker. In fact, we have a sample application in the libnetwork project called the DNet, which doesn't require Docker at all. but it can create sandboxes, it can create endpoints, it can create networks and connect them together to form a fully functional container networking, just working without having the need for a container actually around there. We can just use Linux primitives like the namespace, v8 interfaces, VXLAN devices to make a reasonable Linux networking just work with namespaces, which Docker actually makes use of by calling the management APIs of the lib network, the CNM APIs essentially. So as you can see here, a container wraps the sandbox. It's a one-to-one correspondence between the container and the sandbox, and things just work for a container because of the way the Docker makes use of the lib network. So the way it works is Docker today uses something called a container D for its runtime execution. So after the container is created, a namespace is actually created at the runc level, and that namespace is sent to the lib network in order to form the sandbox and then plumb the endpoints inside and connect to the appropriate network. So if you look at this abstraction here, you can pretty much see that you can have multiple networks created, and a sandbox can be attached to multiple networks at the same time. And each network can be managed by different plugins and different drivers, depending on various requirements that people have. There is an one-to-one correspondence between an endpoint and the network. So I can have one endpoint connected to one network, but a sandbox can have multiple endpoints, so it can be connected to multiple networks. And each network by default is isolated from other network. So there is the isolation is like provided at the network level, and a container can just wrap a sandbox so that it gets all the properties of the lib network. So essentially, if you look at the Docker code today and how it interacts with lib network, all the networking complexities are hidden inside lib networks, drivers, and control plane, while Docker itself is kind of oblivious of how the networking is done. All it cares about is sandboxes, networks, and endpoints, and that's all to it, pretty much. And since lib network is primarily used by Docker today, so Docker's management plane is directly hooked onto the lib network. So any Docker CLI like the Docker network create, Docker service create, so on and so forth, will call the management APIs of the lib network, which are essentially the CNM objects. And that's how we are able to create such an abstraction overall, essentially. And if you look at it, the Docker Compose is another management plane on top of Docker APIs. So the same Docker management interfaces that we know is made use by Docker Stack and Docker Compose file, and that get translated into CNM APIs, management APIs, that creates a network object and endpoint objects. And then finally, it calls the driver APIs. That's for plumbing the traffic from A to B, or allocating IPAM addresses, so on and so forth. Okay, these are all more details which we covered already. I'm going to just skip this. So lib network, as I said, it's the implementation of CNM. This is a library that contains everything that is required to create and manage container networks. As I said, it's a library. It can be used not just in Docker, but it can be used anywhere. It provides built-in service discovery, load balancing, which is shared by all the drivers. So this is the critical piece here. So the way the CNM abstraction kind of differs from the way CNI thinks about the driver interfaces is exactly here, where the way CNM thinks about the complexity of the networking is that the CNM tries to keep the plugin APIs in a composable way, in a sense that if I want to have, if we go back to this one here, if I want to have a container attached to multiple networks with each networks managed by different plugins, then we need a way for an arbitration done there. So to make sure that a container doesn't get, the user controls the way the network namespace happens in the container. Essentially, we don't want one plugin overwriting say, static route of another plugin installed there, or a plugin taking over the DNS services, or there's a conflict between load balancing rules, and so on and so forth. So in order to achieve that, the way CNM defines the model in the sense that every plugin gets a very control APIs. So these APIs are designed to do one thing and one thing really well. So network driver today doesn't do IPAM interfaces. IPAM has a different driver interfaces, while network has a different network interface. And now we are working with various plugins now, service discovery plugin and load balancing plugin and so on and so forth. So that once we have these composable components, we can provide guarantees for the application stack, which is running above the platform, that having different plugins will not cause conflicts or will not cause portability issues when you move application from a desktop to the cloud, essentially, right? So a user can actually use a bridge driver on the laptop, and then they can move to the on-prem. They can move the same application just by moving to the Mac VLAN driver. The same application will work with no changes. And when it goes to the cloud, if Mac VLAN doesn't work, they can use overlay or the native cloud platform networking without changing the application stack in any way, right? That's the goal that we are working towards. So in order to provide such a lofty goal, we have to make sure that each driver API is composable in a way that it doesn't corrupt some of the drivers that is assuming its own functionality there. So what it is, the CNM itself, that if you look at the driver APIs, that today we don't use CNI here, we use the driver APIs provided by Docker. So the difference between CNI and the driver APIs that we have today is that the driver APIs in the CNM, we don't pass the network namespace to the drivers, because the moment you pass the network namespace to the drivers, then if you have multiple drivers managing the same sandbox, then there can be conflicts and we cannot provide the guarantees required for portability. So what we have done is, in the libnetwork manages the network namespace, while the drivers gets the individual APIs, so that drivers can do the plumbing, but the final work of manipulating the final namespace is done at the libnetwork level. So that actually proved to be extremely helpful, because they're able to provide the common service discovery and load balancing, which is shared by all drivers. So one can implement any network driver today. For example, if you want to implement a network driver today, it'll just continue to work the same way, because the load balancing, the code that we implemented with IPPS, it's all plumbed in by the libnetwork code. That way we don't actually have to deal with driver X working on load balancing solution, driver Y working on different load balancing solution, then they don't work properly when you move the application from one platform to other platform, right? So that's a primary that's primary difference between these two APIs. And that proved to be really, really helpful for us, where we are able to innovate on the service discovery and load balancing without having to impact on the drivers, because drivers doesn't control the network namespace. So that's a big difference there. That's actually very helpful when it comes to portability. And we have a consistent version APIs thanks to Docker APIs today, which we make use of it there. And of course, we have plugin model. The driver APIs are the same driver APIs used for both the built-in native drivers and also third-party external plugins. And libnetwork today is multi-platform, so it can work for both Windows and Linux. And most of the drivers are compatible. For example, the overlay driver works between Windows and Linux. And currently, we are working with the Mac VLAN driver to be compatible as well, so that when customers deploy Docker or any solution based on libnetwork, they can natively work on multiple platforms without having to worry about different solutions for different platforms, essentially.
Can I ask a question?
Yeah, go ahead.
So this is G. So one question I have is like you mentioned load balancing and the service discovery. My question is like, it sounds like these two are very related to the container orchestration system. Like I want to get the information about all the backend IP and port, things like that. So is there an interface to hook with lib network, or it's very specific to Docker?
Oh yeah, it's a good question. So libnetwork is an independent project, right? So libnetwork has its own project, so things just work today. But what is the management interface today is via the Docker today, right? So what we are working on today right now is that to unplug the service discovery and load balancing into its own components and provide management APIs at libnetwork level. Today, the management APIs at the Docker level. That's why we don't see libnetwork CNM APIs for these service discovery and load balancing. But what we are working on right now is to expose the CNMs. We are enhancing the CNM APIs to provide both service discovery and load balancing primitives. That way, we can use this directly independent of Docker. That's the one we're working on right now. And also, one interesting thing that we're working on right now is to make service discovery and load balancing also pluggable. And that way, as you said, different platforms can choose to use different way of load balancing. So today, the load balancing done at the libnetwork level is done using IPBS, and service discovery is done using built-in DNS. If some platform requires a different way of load balancing, for example, they don't believe in L4 load balancing, they want to do only L7, then they can replace the IPBS with some other load balancing mechanisms, right? So that's exactly what we're working on right now.
All right, thanks. Thank you very much.
Sure. Right. So as you can see here, again, the libnetwork architecture is pretty straightforward. Libnetwork is based on CNM APIs. Libnetwork implements load balancing, service discovery, and the control plane. So the control plane is also today common service today, and of course, drivers can choose to ignore it, but today we provide it. So a network driver can simply be doing their data plane alone, while the control plane can also be abstracted at the libnetwork level. Libnetwork today uses the gossip mechanism for exchanging the control plane. But some drivers like Mac VLAN and Bridge doesn't even use it, which is fine. But overlay makes use of such a control plane today using gossip. And we have native IPAM driver, also plugins for network plugin and IPAM plugin. And this will be expanded shortly to include service discovery and load balancing as well. And Docker engine, as you can see here, the interaction with the Docker engine is purely at the management plane. Once the Docker engine gives the control to the CNM, then CNM does all the rest of the work.
So we have probably just a couple of minutes left. Are there any questions from Madhu? We can always pick this up in another.
Yeah, this is the last
session,
slide.
Madhu.
This is the last slide, and I'm done.
I just want to make sure we get all. I knew there were questions. I just want to make sure we get a couple of questions out. So go ahead and finish the slide, and then if you guys have a question or two, be ready to ask it.
Yeah, this last slide. This is again like summary of what the original design goal was and what we are working towards, how we are working towards it, and it's again a summary of everything about what CNM is, what the goal was, and how libnetwork helps achieve the goal, and how we originally saw the way abstraction should be done, and what we have done so far. So we are really happy so far. And the one thing that we are clear about is the driver APIs. It's very clear most of the plugins really would like to have a CNI interface because of the commonality that we see between various projects, and it absolutely makes sense. So we are actually implementing CNI-based driver APIs. So still CNM still is going to do the management interface objects that really helpful for us to provide the portability, while the driver APIs can still be a CNI, so that all the CNI plugins out there can just continue to work in libnetwork with all the jazz that I explained so far.
Right.
Okay, with that, I'm done. Questions?
Great.
So I didn't quite follow. What's the purpose of the distributed control plane? Setting out there in the entire CNM. Why is it part of the model?
Sorry, what is it? Sorry.
So so you have the distributed control plane, a gossip-based distributed control plane that's actually part of this entire CNM model. So I was just wondering what exactly is the purpose of having an entire distributed control plane sitting? So probably the question is, what is this control plane doing? Is it just an opinionated way of doing routing and switching, or it's a general API to get IP addresses for containers? I'm not exactly sure what the purpose of that distributed control plane out there is.
All right, distributed control plane is purely a KV store kind of an approach where if you want to distribute a key value, and the control plane will distribute it for you, right, across the cluster. So what is the data that goes inside is entirely driven by the driver. So you can have your own driver, right? The driver can want to distribute, in this case, an overlay driver, want to distribute neighbor reachability, where, hey, I want to reach a particular MAC behind a particular VTEP. Then the driver can let the control plane know that, hey, I want to send this key and this value, send it to the neighbors for me, right? Then it's sent it across. And similarly, distributed control plane is used today for, again, it's KV store. There are multiple, like, it's not KV store, it's a KV gossip-based mechanism. So it's used by multiple applications today. One of it is the drivers, when many drivers we make use of it for distributing the states without having to do BGP and other stuff. So today we just make use of this one, and also service discovery. So if you want to do service discovery across the cluster, then things just work because of the way we distribute the states across the cluster.
Yeah, I guess the follow-up question on this one is like, does this distributed control plane be part of CNM or the implementation of CNM, which is LIM network?
It's an implementation of it. So it's an implementation of CNM.
Okay.
The reason why it's implementation detail is that CNM, the concept of CNM, there's a thing called network object. Network object is an abstraction for a network, whether it is within the single node or multiple nodes. Doesn't matter. Network should just work across multiple nodes. If things are to work across multiple nodes, then of course we need a control plane. Of course we need a mechanism to distribute service discovery. So service discovery, control plane, they're all implementation detail of CNM. It's not CNM APIs, it's lib network, how it interrupt. It's the implementation of CNM essentially. So distributed control plane is absolutely not required. In fact, it's not even used by few drivers, but it's a service provided by lib network for a CNM driven object to make use of essentially.
Got it. Thanks.
Yeah. And
yeah,
go ahead. Sorry.
No, I want to ask a question. Why don't you finish your thought and I can ask a quick question?
Sure. Yeah. I want to bring up the point of encryption. So we provide encrypted data path and also control path. Everything is fully encrypted end to end. So it's a very, very important concept where we want to make sure that, again, from portability standpoint, folks who try an application in their stack, even from security angle, they want to make sure that their stack doesn't fail when they deploy it in the production. So we made sure that from ground up, everything is fully encrypted end to end. So what you see is what you get when it comes to deploying application, whether it's in laptop or in cloud, essentially. Yeah, go on, Manshu.
So I just wanted to know if you can give a quick example of the layering that you talked about, like between CNM and CNI. I'm still not very clear. So if you can just give like one example, yeah.
Absolutely, yes. So it's actually pretty straightforward. It's a matter of getting it done. So what happens is, I don't have a slide for it for now, but I can explain it to you. So imagine lib network is a component, right? Just like containerd is. So think about Docker as a project. Docker today, what it does is it calls lib network APIs, like the CNM management APIs, for creating network object, creating endpoint object, creating sandbox object, right? Creating those objects alone has no meaning whatsoever. The only meaning comes in only when it gets plumbed into the container namespace. So what happens today is when Docker creates the container, it uses containerd for creating the container. Containerd uses OCI runtime, the runc, right, for creating the container itself. So what runc does is runc actually creates, when it creates a container, it creates all the namespaces, including network namespace. So network namespace is passed from run C to containerd, and from there it comes to the lib network. Only after we get the namespace, we actually plumb the namespace with the sandbox. So that's what we do. So what we did in CNM is the driver APIs that goes from the lib network to the drivers. We call the create endpoint and attach sandbox and whatnot, which is very, very similar to what CNA does today. The only difference is we don't pass the network, the sandbox, the namespace that is sent by the containerd to the drivers, right? So we can essentially have two different plugin interface now. One is the plugin interface that we currently have, the driver APIs, where we don't send the network interface and network sandbox, the network namespace. We can extend it to include CNI and say that, hey, you can also use CNI plugins with this architecture, because we have all the information that we have to send it to that. We have the exact callback, because callback eventually is the containerd doing the create of the network. The same sandbox is going to be available for us. So we are going to do the CNI plugin as well. The only drawback will be that if it is a CNI based plugin, then the container cannot run with multiple network drivers, because CNI, since we cannot guarantee the behavior of how one plugin can manipulate the network namespace, so we have to restrict to one network per container. That will be the only restriction if you go with CNI.
One network per container or one network driver per environment, like per cluster?
No, it should be one network driver per container, right? Not
per container.
Okay, one network driver. Okay, got it.
Yeah. So it's actually pretty straightforward to do, and based on the discussion we had in the past things, and CNA is part of the CNCF, it's pretty simple for us to extend the network driver to support the existing driver plugins, which is because we want to continue to supporting multiple network plugins per container. We want to continue doing that for various reasons. But if the customer is interested in trying a CNA plugin, then it can also work without supporting multiple drivers per container, essentially.
Yeah, perfect. Thanks, Madhu, for the overview. I know this was very quick, and I'm sure there are more questions. I think one of my objectives was to sort of have this overview, and then next week, in 2 weeks, we have a couple more projects presenting. But then the 2 weeks after that, I want to kind of come back and revisit, the network work group charter and what we want to work on next. And so a lot of the concepts you brought up today with the service discovery, load balancing, some of the modeling pieces, right? I want to kind of go deeper into that and spend an entire meeting on sort of how do we, work closer together on CNI plugins, lib network, and CMN. So for those of you interested in this, about a month from now, we'll be going deeper onto this and trying to figure out what we tackle next as a work group. So
yep, let's do it.
Great, thanks, Madhu.
Sure.
So Himanshu or Rohit, whichever one of you wants to take over the screen and start sharing project Contiv. Please. Please go ahead.
Himanshu is gonna start sharing and take the lead on the presentation.
Hey guys, do you guys see the slides?
Yep.
Okay, great. And I believe Ed is also on the call. So Ed and I, we are gonna talk about Project Contiv in brief. The agenda is really to give a high-level overview of Project Contiv, what it is, where it has been, where it's going, with a little bit of flavor of the community that we are building around it, and sort of, give that kind of information to the community. So, you know, everything about Contiv is open source, and this link takes you, Contiv.io takes you to all of the, you know, documentation and code and everything. So just to get started here. So, what is Contiv's approach to containers, right? I mean, containers, as they're becoming more and more popular, Contiv is effectively built around the ideas that sort of got popularized or became mainstream with, you know, container adoption. So that means, you know, thinking in terms of these various different facets of you know, containers. So, you know, in terms of the scale, in particular, how we do, you know, route and policy distribution in Contiv that directly, you know, associates with and relates to the scale aspect of it. Speed and agility part, as, you know, containers quickly come and go, how Contiv handles that across the whole, you know, cluster. In terms of layering, layers of network, how Contiv, you know, does like flat networking to provide very high performance and not only have like overlay as an option, but have multiple options so that you can have high performance and high visibility. More on the application-centric design. So Contiv is a networking project. It's a container networking project, and but again, you know, just like Madhu described, you know, it's built with the application-centric structure in mind. So when you are building your containers and your applications together, how you're thinking in terms of networking. So some of the concepts that we just heard, exactly the same idea. How do you take the information or the intent that the DevOps guy describing in terms of his application, and how to distill that into networking information. In terms of how to do, you know, best resource sharing, and there, you know, Contiv has policies at different levels to do better resource sharing across the whole, you know, whole container landscape. Hybrid cloud models, so that you don't have, you know, it can run both on-premise and in cloud. You know, security, so that it has, you know, security and isolation policies built right in. So, you know, the kind of security guarantees that you want for your containers, you know, Contiv is able to deliver that at the networking level. And, you know, the end-to-end sort of telemetry and diagnostics that people expect. You know, Contiv has that built in terms of the networking flows and, you know, endpoints and so on. So this, you know, is kind of like a high-level, you know, approach as to how Contiv integrates with the rest of the container ecosystem. Just double-clicking a little bit in terms of specific aspects of how we are doing these things. So things like, you know, we provide support for multiple underlay networking nodes, so that you know, you can use overlay, for example, in a cloud setting, and you can use either a layer 2 or layer 3 in your on-premise setting. Contiv has built-in multi-tenancy and isolation support, so that when you're running a network across multiple hosts, multiple tenants, all of the different containers or different tenants are isolated from each other. Contiv provides, you know, the security and isolation policies, where you can have the security group-like rules to describe what is allowed, what is not allowed. It has built-in support for traffic prioritization and bandwidth policies, so you can dictate, you know, what kind of performance your applications container flows will get in certain environments. Network monitoring, as I said, you know, built in, and as well as these other aspects like, you know, integrated IPAM, load balancing, and so on. In terms of just again, a high-level view of how this all, what are the different pieces and how they are structured in the whole, starting from the utmost layer down to the infrastructure, the whole the solution, how it comes around. So at the topmost layer, we have a management entity. It's labeled here as Contiv policy manager. Really, it's the management entity using which users create and describe the policies, the different policies that they would like applied in the system. And then the second piece is a policy distribution framework, much like what Madhu was pointing to, the distributed control plane. We have a similar, control plane where all of these policies are distributed across the whole cluster. This is very well integrated with the different orchestrators, container orchestrators that we have available, including Docker, Kubernetes, Nomad, Mesos, and on each node level, we have a plugin component that is running, that is providing both a policy enforcement point as well as a networking plugin for these different architectures. So the networking plugin aspect enables, of course, various container networking scenarios, both inter-container and outside, scenarios. But the policy enforcement point is where all of the, policy enforcement comes about, how your containers are going to talk to each other or to external entities. And then all of this layer, the policy layer is then integrated underneath with the physical infrastructure to do, policies around networking, as well as we have, work in progress to do policies around storage as well. And all of this is sort of, vendor independent. It is built on standard, networking and storage concepts, as well as we have integrations with other network providers as well. Somebody had a question, or I heard some noise. Okay.
So I was just trying to understand, what do you mean by, so I understand policy enforcement in terms of network in the context of this talk. I was just trying to understand what you mean by policy enforcement in terms of compute and storage. This is Avinash, by the way.
Okay, hi Avinash. So it's so generic idea that, in terms of the storage, for example, the policy enforcement is how much storage, what's your quota? That's the simplest example. Whether you are allowed to consume a particular type of storage or not. Those are all the policies, for example, you can do for storage. Compute, some of the compute policies that you might, that container system already provide, like how many file descriptors you can open or things like that. So those are, in terms of these, so this, what it shows here is the overall policy enforcement layer, not just Contiv, right? So compute, for example, is being provided today by the different container runtime and orchestrators. Network, the storage, some part of it is provided by the storage vendors and storage driver providers, and we are working on some of those aspects. And network, of course, is what Contiv provides. Does that answer your question?
Yeah, got it. Sounds good. Thanks.
Okay. All right. So just in terms of what we are, this is just a recap, high-level slide of a lot of what we are, providing today in its entirety as the product stands today. Let me just quickly build this slide out. Sorry. So this is the state of the art today. So the Contiv project is about a year and a half or so old. We have a version 1.0 that is out there with both community support as well as technical support available from Cisco. And what we provide today, again, is a networking solution, a container networking solution that can run on any infrastructure, whether we mean, either on bare metal or on virtual machines. We can use, multiple types of, underlay networking technologies. We can use many container platforms, including Kubernetes, OpenShift, Docker, and etc. From a DevOps perspective, Contiv allows you to declare, the policy intent and the connectivity and performance intent via its policies. And from a network admin side of things, Contiv is providing not only just the connectivity, the network connectivity piece, but also some of the aspects of role-based access control and integration with enterprise LDAP directories and so on to help people deploy this in the enterprise. So, apart from just the core networking piece, which is the major piece of Contiv, there is also a significant work around making it easy to deploy and some of the security and enterprise angles around it that makes it valuable in the in an enterprise setting. And as I mentioned earlier, also Contiv project is 100% open source project. So this slide kind of shows where we are at and where we are going in future. So in terms of, and this shows like 3 dimensions that I believe community sort of cares about. One is the kind of networking models. So we already, CNI is pretty well adopted. CNM also in the Docker landscape, and we support both of those. And Contiv also has its own sort of network object model that is there underneath, which supports CNI and CNM on top. And then some of that object model, if you want to enhance it or update it, that's where you would update that. And then we have support for things like Kubernetes network policy. So again, supporting more and more of the models that are out there in the community, and that work is coming soon in the upcoming release. In terms of our integrations with existing platforms, again, I mentioned a few earlier, and from monitoring aspect, we have Prometheus integration and work that again will be coming soon. The data plane aspect of Contiv is also pluggable, if you will. So right now, the main data plane is Open vSwitch based, but we have in work the FIDO integration, the VPP integration that allows for the SRIOV and DPDK-like techniques to do user land networking and to provide potentially faster container networking. So that's sort of the technical aspects of Contiv. I would like to hand over to Ed, who would like to add a bit more around the community aspects of Contiv and where we are taking this project. Ed,
thanks so much. Before you jump in, Ed, I know we're coming up on like 5 minutes to the top of the hour. So if there are, I know I can stay a little bit later if there are any like people who have to drop at the top of the hour and you have any burning questions, I want to give you a couple minutes to sort of ask those questions before Ed jumps into the community side.
Okay, that sounds good.
Great job, good overview, and I think it's very, very clear. So good job, guys. Any questions before we jump into the community aspect?
Well, then it's all clear.
Yeah, it's clear. Yeah, no, this group would definitely be asking questions if they have. They're not shy. So, all right, Ed, jump on, keep on going with the community side.
That would be probably most expeditious in terms of time. So
Sorry, yeah, I'll move the slide there. Is that which one?
just next slide.
Yep. Okay.
Cool. I just wanted to talk a little bit about the community around Contiv. I often find it very helpful when talking about that to sort of run through a few code activity numbers. So when you look at the commit history for Contiv, you find well over 3,000 commits have come in from, order of about 84 contributors from what look like 33 organizations. Anyone who actually runs organization stats realizes that gets fuzzy quickly. God bless you, Gmail. And so there is a very active and broad community engaged in Contiv development. Next slide. So Contiv is in the process of actually bringing good, solid, open governance to the project. And as part of doing that, it's moving towards a committer model, where basically you have different groupings of repos for the code base that represent different aspects of what's going on in Contiv. So core networking, deployment, REST APIs and object models, documentation, and testing. Each of those groupings of repos, each of those projects, if you will, have their own set of committers that will be making their own technical decisions based upon typically the consensus of those committers. And as in most places, a committer is someone who can merge code into the repo. Next slide. And so the last one is sort of adopters, adopters and partners who are involved. So there are approximately 25 currently. They include folks like SAP, Nirmata, Tata Telecom, Presidio. Obviously, Cisco is involved. Docker and Red Hat are part of the ecosystem around Contiv as well. So there's a growing community of people who are involved, adopting, developing, etc., around Contiv.
I think that's pretty much all we have in terms of the overall presentation at this point. Yeah.
And then just one last question for the Contiv team. What is your interest in like participating in the CNCF, and what are your thoughts around like working closer with the CNCF?
And you want to take that first?
Yeah, so I mean, I think the Contiv project would very much like to draw closer to the CNCF community. That seems to be where a very strong center of gravity for working around these sorts of things is occurring. So we're very interested in moving closer to the CNCF community.
Yeah,
and again,
yeah.
Go ahead,
sorry.
Himanshu.
Go ahead, please.
No,
No,
I was just
going to ask you. Sorry, back off. Random back off. You go.
Okay, I was just going to say again, in addition to what Ed mentioned, I think as we plan to reconcile, or I would say include these different networking models, and also try to think about how we add value-added services from a networking perspective to these models, especially in the microservices and going forward into the serverless domain and things like that. I think projects such as Contiv and the other community players will play a very critical role in innovating that in the open and defining what that looks like. So I think the networking subgroup is a very key aspect of that, bringing together all of these different players, and for us to continue to innovate in the open to enable that vision.
Great. So before we wrap up, are there any other questions for the Contiv project team?
I know Himanshu had a comment. I had cut him twice. So.
No, I think you said it pretty much what I wanted to say, which is we are actually looking forward to more, engaging with the networking community and to see how we can sort of make it part of CNCF somehow, make Contiv part of CNCF, as well as innovate in open, right? I mean, that's what Rohit said. So work together with the community.
Quick question, so Himan, can you speak to roadmap items, forthcoming functionality that?
Right. Yeah, that's so a couple of the slivers were sort of shown on the slide, but in terms of our upcoming roadmap integration with VPP or FIDO project, as well as Prometheus integration to make it more sort of consumable in the on the monitoring side. Those are the two immediate things we are working on. And the next set of the somewhat longer timeline things that we are looking at are better integrations with the cloud provider aspect, right? I mean, in different, like, in Azure virtual networking side or on the OpenStack networking side, how to do better integration so that we can leverage some of the functionalities that the underlying layer is providing us, basically. So those are some of the upcoming roadmap items.
So that actually segues me to a quick question. I'll put on one of my many hats, in this case, the FIDO TSC chair hat. Would this group be interested in hearing a little bit more about FIDO? Because it is, particularly in container space, it has a lot to offer in terms of not only increased performance and scale, but also in terms of radically increasing the possible density of containers that you could put onto a box. Often we just sort of take data planes as a given, but we have an exciting new set of possibilities coming from the FIDO direction in terms of full-featured user space data planes that could be used very, very nicely with containers.
Yeah, I definitely had plans. I took a note down earlier to get a FIDO presentation scheduled. So there's definitely, I think, interest in at least learning more about what those interesting opportunities are. I don't know if we're going to do anything with them, but I think discussing what's possible and how, especially when it comes to like cloud native patterns, and which I think FIDO has some interesting use cases for, but I might be just a little bit biased, so I'll have to have you present it to the community, and then we'll discuss it. But I'll work with you offline to get something scheduled. Great. Well, I think everyone's being quiet, so I must have had all their questions answered. So good job today. I'd like to thank Madhu and the Contiv team for presenting what you presented, and look forward to we're getting notes out. We did record this, so there'll be a recording going out as well. The mailing list, if you haven't joined it yet, I think in the chat I sent a email. You can go to that site and learn how to join the mailing list. And we will be meeting in 2 weeks at the same time. And I think the bridge is the same every meeting, but if it's not, just check the calendar on CNCF, and they'll have the latest bridge. So thanks everyone for your time today, and look forward to continuing the discussion in a couple of weeks.
Thanks, Ken, for the opportunity, and thanks everyone. Looking forward to collaboration.
Bye. Thank you.
Take care.